All right, so all but 8 of you were absent from class today. I don't have enough time to repeat the lesson tomorrow, so I'm going to go over the worksheet through this video. So what we're talking about was something called Pythagorean identities for trig expressions. Let's take a look at the do now first. That was a little bit of a review of yesterday's lesson. So number 1 says convert 1 radian to degrees and sketch the angle in standard form. Well, when you're going from radian to degrees, you multiply by 180 over pi. And since it's 1 radian, so 1 times 180 over pi. And that gives you approximately 57.3 degrees if you type that into your calculator. Now make sure you're using the pi button and not just 3.14. And if we're going to sketch that in standard form, that means that my angle starting out at the 0 degree mark and then 57.3 would be right around here in the first quadrant. So that's 57.3 degrees, or you can think of that as 1 radian. All right, number 2, I'm going to show you 2 different ways. One is keeping it in radian form, and the second way is going to be converting it over to degrees. So first, let's try keeping it in radian form. So if I have an angle of 4 pi over 3, keep in mind that 1 pi would be the same thing as saying 3 pi over 3. So 4 pi over 3 would just be a little bit past that. So it would be over here in the third quadrant. And then if you remember, our Alvin, Simon, Theodore are chipmunks. So in the third quadrant, only tangent is positive. So tangent or cotangent, which means that secant would be negative. Now function is secant, which is the reciprocal of cosine, So that would be the same thing as saying 1 over cosine. And our reference angle, what's nice about keeping it in radians is since 4 pi over 3 is already simplified, my reference angle is just going to be the pi over 3. So if I take a look at my exact value chart, the cosine of pi over 3 is going to be 1/2. And keep in mind that we knew that this was negative, so it should be negative 1/2. Now that's the value for cosine. If I wanted the secant, it's the reciprocal, so I'm just going to flip that fraction. So the secant of 4 pi over 3 is equal to negative 2 over 1, or just negative 2. So now I'm going to show you how to do this same exact question if you wanted to convert it to degrees first. So I'm going to write that back on the left-hand side. So the first thing I would do is I would convert 4 pi over 3 to degrees by multiplying by 180 over pi. Now my pi's cancel, so I'm really just doing 4 times 180 over 3. And a shortcut would be I could replace that pi that we had originally with 180. And when I do that, I get 240 degrees. So really they're asking us for the secant of 240 degrees. And then you don't really have to worry about radians. So it's a little bit easier for some of you to picture that 240 degrees is in quadrant number 3. Once again, only tangent's positive there, so secant's negative. And the reference angle would be 240 minus 180, so that would be 60 degrees. So essentially we're doing the exact same thing. It's just a lot easier for some people to picture it using degrees rather than radians. So cosine or negative cosine of 60 degrees, you would go to the unit exact value chart and get negative 1/2. So taking the reciprocal of that, you would get negative 2 for your secant. So very similar, but it just depends on how well you can recognize your reference angles and your quadrants from radians, or do you like it better doing that in degrees? Okay, so here's the actual lesson for today. So I have my unit circle over here. Remember that the x value of a coordinate is always the cosine of the angle, and the y value is always the sine. And I have my right triangle over here. Now this is a unit circle, which is why the radius is 1. So that's the hypotenuse of our right triangle. So just by using Pythagorean theorem, I know if I square the legs, it's equal to the square of the hypotenuse. or a squared plus b squared equals c squared. So in this case, x squared plus y squared would equal 1 squared. Well, I know x is the same thing as saying cosine. So I could say cosine squared of the angle theta plus y is the same thing as saying sine, so sine squared of the angle theta equals 1 squared, which is just 1. And that is our Pythagorean identity. Now, one thing I just want to mention is that the whole idea of having the squared after the cosine and not at the end is because if you write it like this, it looks like you're squaring the angle, whereas we're doing cosine of theta times itself. So instead of having to write it with parentheses, we just write it as cos squared theta. All right, so let's take a look at some Regents questions. So problem number 1, if sine squared of 32 degrees plus cos squared of m degrees is equal to 1, then m equals, well, this only works if that angle is exactly the same. So if you have, it must have been m for both of those. So our m must be the 32. That's simple. Number 2 is a little bit more interesting. So number 2 says determine the exact value of cosine of x if sine squared x equals 4/9 and angle x is located in quadrant 3. Well, the quadrant 3 is important because if I'm looking for the value of cosine and I'm in quadrant 3, then I know that only tangent is positive there. So then cosine is going to have to be negative. Okay, so using our Pythagorean identity up top, they gave us sine squared of x. They told us it was 4/9, so I can replace that with 4/9. So 4/9 plus cos squared x equals 1. If I'm trying to get cosine squared by itself, I'm going to subtract the 4/9 to the other side. And I'm going to get cos squared x equals 5/9. And now if I want to get just cosine of x, because right now I have cosine squared, I'm going to take the square root of those. So now this gives me that cosine of x is equal to the square root of 5 over, and square root of 9 is just 3. But keep in mind, we said we were in quadrant 3 before, so I know that this has to be negative. And there's my answer. All right, so a slight variation here. This one actually came from a Regent. Notice how they were nice to you and they gave you the Pythagorean identity in the question. So it says, using the identity sine squared theta plus cos squared theta equals 1, find the value of tangent of theta to the nearest hundredth, so we are going to have to round here, if cosine theta equals negative 0.7 and theta is in quadrant 2. All right, so if cosine theta is equal to negative 0.7, then cosine squared theta would be equal to negative 0.7 squared. Notice how I put parentheses around that. And that would give me 0.49. Now remember, they said we were in quadrant 2. So quadrant 2, if I'm looking for tangent, I know that tangent is going to be negative in that quadrant. So my final answer will be a negative. I need to figure out the value of sine, though, because keep in mind that tangent of an angle is equal to the sine of that angle over the cosine of the angle. So I know the cosine, but I don't know the sine yet. That's where the trig identity comes in. So I'm going to replace what I know. So I don't know sine squared theta, but I do know that cos squared theta is 0.49. If I subtract that over to the other side, I wind up with sine squared theta equals 0.51. So I'm going to take the square root of both sides. So sine of theta equals the square root of 0.51. Now notice how I didn't type that into the calculator yet because I want to save all of my rounding for the very last step. So I'm going to go back over here to the definition of tangent, and it's sine, which is square root of 0.51, over cosine, which was negative 0.7. And that lets me know, if I divide that on the calculator, I'm going to get negative 1.02. So that was equal to the tangent of theta. All right, number 4, using the unit circle below, explain why cosecant theta is equal to 1 over y. This one doesn't have to do with the Pythagorean identities, but I thought it was a good little practice Regents question because we haven't been talking so much about reciprocal functions lately. So keep in mind that cosecant is the reciprocal of sine. And we also know that the y value of a point is equal to sine of theta. So if I put those two facts together, then that must mean that cosecant of theta has to equal 1 over y. Okay, my last one. So it says determine the exact value of cotangent of x. Now keep in mind that's the reciprocal of tangent. Tangent is sine over cosine, so cotangent must be the reciprocal of that, so it must be cosine over sine. Now secant squared is the reciprocal of cosine. So if I know secant squared equals 25 over 9, I know that cosine squared has to be the reciprocal of that, so 9 over 25. By taking the square root of both sides, I end up with cosine of x is equal to 3/5. So I'm going to use my Pythagorean identity again. And if I plug in for my cos squared, well, I guess I didn't really have to figure out that cosine x equals 3/5 because I'm going to plug back into cosine squared anyway. But I'm probably going to use that later. So sorry, this is late as I'm making this. All right, sorry about the little mess up there. So sine squared x plus cosine squared x, which is 9 over 25, equals 1. When I subtract the 9 over 25 to both sides, I wind up with sine squared equals 16 over 25. So I'm going to take the square root of both sides. And now I know that sine of x is equal to 4 over 5. Now keep in mind we're in second quadrant. So in second quadrant, the cosine is really negative. The sine is positive. So when I divide a negative by a positive for my cotangent, I'm going to wind up with a negative answer. So negative 3/5 divided by 4/5. Since my denominators are exactly the same, they cancel, and I get negative 3 over 4 as my final answer. All right, that's a recap of everything that we talked about today in class on April 26th. And tomorrow we're going to start graphing trig functions. See you then.